Okay, today we're going to be going over 8.5, proving triangle similarity by side, 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 and side angle side. So the side, side, side similarity theorem says if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So notice that you're going to have to figure out which are the corresponding sides first. So when they look alike and they're in the same position, it's pretty easy to tell. So I would look at AB compared to RS. If that proportion is the same as AC to RT and BC to ST, then you're going to have a similar triangle. Okay, so you can see those ratios written up for you right there. Okay, so they want you to use the side, side, side similarity theorem to find out if any of these triangles are similar. Okay, if either of these are similar to ABC. So what they did, here's their first step, is they're comparing ABC and DEF by finding the ratios of the corresponding sides. Before you worry that you can't tell what the corresponding sides are, just go small, medium, large. So here's my small one. I go over here, here's my small one. Okay, they've got them color-coded, but in your case, you're not always going to have that information. And don't get fooled by them looking, being the same number. Those are not the corresponding sides. So the 12 is the medium size. It would correspond to that one. So that's how you're going to do it. Then the next thing you have to know is what are you putting on top in your ratio? Since they told you to compare that, they're putting the information for triangle ABC on top. And it's got to stay on top all the way across. Otherwise, your ratios will be messed up. So they took the triangle and they did the corresponding sides, and they found that each of the ratios was the same. So therefore, triangle ABC is similar to DEF. Okay, now we're going to check ABC to GHJ. All right, so again, you have to look at which side is the smallest. So in this one, 8 is the smallest side, and 10 is the medium size. They're still putting triangle ABC on top, so make sure your sides for ABC are always on top. Then they put the other ones, and they got 1, 1, and then they got this. All you need is one side not being the same ratio to prove that they are not similar. Okay, so they want you to determine whether triangle RST is similar to ABC. So what I'm going to do first is I'm going to look for which side would correspond to which side. So here's side, the smallest side. Here's the smallest side. I have to figure this out. This is 2 2/5. 2 2/5. So this one is my medium side. And that leaves this one to be the largest side. Okay, so I'm going to put triangle ABC on top. And I'm going to compare it to triangle RST. So I'm going to first do my small side. And you don't have to write down all these extra information. I'm just showing you methodically what you want to do. So this would be 2.5 divided by 1, which is 5 over 2. Okay? So do the work. 2.5 is 5 over 2. 5 over 2 divided by 1 is 5 over 2. Okay, so now we're going to do our medium sides, which would be, remember, I'm doing the biggest to the smallest. You might have done it differently, and that's just 5 over 2, which is 5 over 2. So now we've got that, okay? The last one we're going to do is the largest one, the large side, and this one is 6 to 12 over 5. Now when you're doing this, you need to remember that this is 6 over 1 times 5 over 12, because this is division. So now I'm going to get 30 over 12, which simplifies to 5 over 2. And so these are similar. Okay? Okay, so they want you to use the side-side similarity theorem to find the value of x that makes this true. So we're going to assume that it's true to start with. So we look for our smallest side, and for this one it's AB and ED. So we're going to set up the ratio. AB is to EDE, and that is 4 to 12, which equals 1/3. So now we have the ratio. You could call it the scale factor, but it's the ratio of each side that each side should be. So now I'm going to use that to solve for the other side. So the next one I'm going to do is this one. So I get 1/3 equals x minus 1 over 18. Cross multiply, I get 18 equals, don't forget your parentheses, and I'm going to distribute 3x minus 3. I'm going to add 3 over to the other side. I get 21 equals 3x. Divide by 3, x equals 7. So 7 is the amount that I found that would equal that. That would make this side equal 6. And sure enough, 6 over 18 is 1/3. So now I'm going to plug in 7 here. I get 3 times 7 plus 1 is 8, which is 24, which is 8 over 24 equals 1/3. And so it worked. So that is the value of x that you need. Okay, so here's one for you to try in your journal. If you want to do this on your own and see how you do, go ahead and push pause at this time and then come back when you're ready to go over it. Okay, so the first thing I want to do is I'm going to set up my ratio. So you have to look for the sides that are corresponding that it gives both measurements. And here they are. So I'm going to go ahead and say 5 is to 20 over 3. Okay, now remember, I have put triangle RST on top. So whenever I'm calculating, I have to remember to use the side from RST on the top of my ratio. So this becomes 5 over 1 times 3 over 20. I'm going to cross cancel, and my ratio is 3/4. Okay, so that's the ratio I'm looking for. So now I'm going to compare the next set of sides. I'm going to do RS to GH or HG. And so I've got 3/4 equals 3 over x plus 7. So I'm going to put parentheses. I'm going to distribute as I cross multiply. I get 12 equals 3x plus 21. Subtract 21 from both sides, and I get 9 equals 3x, negative 9. So divide by 3, and I get x equals negative 3. So the first thing I want to do is double check to make sure it's not going to make any of these sides a negative side. So I go negative 3 plus 7 would be 4. Look at that ratio, 3/4. So we're good to go. And then I check this one. 3 minus negative 3 would be 6. And is that 3/4? Yes, it is. So now I know that this is the answer I was looking for. Okay, so now we're going to look at side angle side similarity theorem. And this one is if one angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including this angle. So here's the included angle. So those have to be the sides you're comparing. If those are proportional, then the triangles are similar. Okay? So think about that. Pause if you need to visualize that, and let's try this out. Okay, so they want you to use this side angle side similarity theorem to solve this issue. You're building a lean-to shelter starting from a tree branch right there. You construct the right end, that's this side over here, so that it is similar to the left end using the angle measure and length shown. So they've given you all the measures. They want to know if these two triangles are similar. So the first thing that you should notice is that angle A is congruent to angle F. Okay, that is the only angle that they give you. So now I'm going to check the ratio of the sides that are connected to these angles. Okay, so I'm going to say, I'm first going to compare AB to FG, and that is 9 over 6, which simplifies to 3 over 2. Okay, so those sides are set up in the ratio 3 over 2. Now I'm going to check AC to FH, and I can see that that equals 15 over 10, which is also 3 over 2. So now that I've proved that the sides connected, the two sets of sides connected to the congruent angle are congruent, I've proved that triangle ABC is similar to triangle FGH using the measures shown by the side-angle-side theorem, side-angle-side similarity theorem. You want to make sure you say that. Therefore, you can make the right end similar to the left end, and you'll be safe and dry. Okay, so here's your exit ticket for this one, and you're going to be building 2. Make sure you read the problem carefully because it explains it in detail. So this is the scale model of an actual truss. So make sure you read the problem carefully so that you can understand. Have a good day.